Good afternoon and welcome to the ILIKA PLC post-AGM investor presentation. Throughout this recorded presentation, investors will be in listen-only mode. Questions are encouraged and can be submitted at any time by the Q&A tab situated in the right-hand corner of your screen. Just simply type in your questions and press send. The company may not be in a position to answer every question it receives during the meeting itself. However, the company will review all questions submitted today and publish responses where it is appropriate to do so. Before we begin, I'd like to submit the following poll. I'd now like to hand you over to Graham Purdy, CEO. Good afternoon to you, sir.
Afternoon, Alessandro. Thank you for the introduction, and many thanks to everybody who's taken the time to dial into this IMC presentation. We'll get started straight away with the slides. So we've just had our AGM, and this is a quick update. It's only a couple of months ago, actually, that we had our annual results that we shared with you. But this is a quick update on the day of our AGM. So ILIKA is a specialist in solid-state batteries. We're really one of the few independent global experts in their design and manufacture. There are two product lines. On the one hand, we've got our Stereax miniature cells that are designed for implantable medical devices. And then on the other hand, we've got our large format Goliath pouch cells, which are designed for consumer appliances and also for EVs. And you see each of those different products pictured on this slide here. So why are solid state miniature batteries of interest to the medical device industry? Well, first of all, they're ultra compact, so they occupy about half of the volume of a normal lithium-ion cell, and this enables smaller designs. You can see just how small they are actually from the picture at the top of the right-hand side of this slide, where you see one of our M300 cells alongside a pen and pencil tip. They're also high power density, so they're actually sort of halfway between the performance that you might expect from a traditional lithium-ion cell and a capacitor, in that they can deliver power pulses both for therapy and for communication. Because when you use a communication protocol like Bluetooth, you actually need quite a pulse of current in order to drive the Bluetooth chip and to send that data out of the body to a device that can relay it into the internet. And of course, they're safe. So there's no toxic fluid leakage that's possible. And this is clearly very important if you've got one of these cells, for instance, on a contact lens or indeed implanted in the body. So, what are the applications in medical devices that people are particularly interested in? Well, there's a bit of a revolution that's sweeping through the healthcare industry. And, historically, we've prescribed a lot of chemical-based pharmaceuticals to treat diseases and health conditions. And going forward, people are more interested in how we can leverage the peripheral nervous system in a benign way to be able to deal with some of these conditions and avoid the use of chemical pharmaceuticals that might have toxic side effects or perhaps unwanted social implications. You've probably all heard about the opioid crisis in the US, where increasingly strong painkillers have been prescribed to people in particular with severe lower back pain, and this has triggered an addiction crisis. Well, actually, for treating back pain, you can now use nerve stimulation, and that's not the only condition that you can treat by stimulating the peripheral nervous system. You can deal with other conditions such as involuntary muscle spasms like epilepsy through stimulation. You can deal with depression, Alzheimer's, and of course obesity. One of the major healthcare issues that we're dealing with as a society. as well as rheumatoid arthritis and eating disorders. So the Stereax cells are small enough that you can put them close to one of the most important nerves in the peripheral nervous system, the vagus nerve. It's one of the 12 cranial nerves that connects the brain to the body. And it's a bit of a superhighway that interconnects all sorts of different organs. And that's why actually you can use it to deal with quite a variety of different conditions. So if you've got a Stereax cell, you can actually fit it close to this nerve, and therefore the implant cost and also risk profile is much lower than you would encounter with a much larger battery. Very large market, growing primarily in the US at the moment. Of course, the US is an early adopter for a lot of medical devices, and this is a market that we're very closely engaging with. Here's another example, smart orthodontics, where you actually put a Stereax cell on a device that fits around your teeth. You can actually use such devices for monitoring a series of conditions. Of course, pH is the simplest one, because acidity in saliva is an indicator of potential tooth decay. You can monitor how glucose-rich your saliva is, and that's a lead indicator for diabetes. And then also more sophisticated sensors can pick up different electrolytes, which are key to understanding incipient kidney disease. But of course, you can also just use it as a compliance mechanism for monitoring the use of aligners or retainers, often worn by teenagers, as their mouths are growing and the teeth are aligning, to make sure that actually the aligners are being worn when they're supposed to. So the idea is that you power a little sensor that's embedded into these aligners. It's a type of wearable device. But of course, the battery needs to be really thin. You can't just put a large coin cell onto an aligner, because it would be uncomfortable when you wear it. So it needs to be miniature, it needs to be thin, and of course it needs to be rechargeable so that the aligners can be reused and continue to have their functionality. So what's the Stereax business model? How do we make money out of this technology? Well, we are now a manufacturing company. From this year, we have built our mid-scale fab, which was a scale up from the pilot line that we operated previously for a number of years. We are capable of depositing the cells or batteries in that facility. We actually do that on wafers, in fact, glass wafers. And we use photolithographic techniques for defining the size and format of the cells. We then outsource the dicing of the wafers and also the thinning of the wafers, the remaining substrate, because actually that's just a way of supporting the cell, and that doesn't add any value in terms of the functionality of the cell. So we actually remove some of that substrate. And then in order to get higher capacity, like for instance from the M300, which is a stack of 6 M50 cells, we stack those cells on top of each other and interconnect them. We then form them, which is an industry way of saying that we stabilize the electrochemical performance of the stacks of the batteries. So with every lithium-ion cell, and solid state is included in this, you need to cycle the batteries for a given number of initial charge and discharge cycles before you get a stable performance out of the battery. And that's what forming is. We do that ourselves, and then we test them and send them out to our customers. In terms of future growth, though, of the business, we don't intend to build a string of fabs or manufacturing centers. In fact, what we intend to do is license the technology for larger scale implementation that will allow us to move down the cost curve, where we'll become a design authority, really licensing the IP. We'll probably have the first licensing deployment in the US to be closer to the customers ultimately that are interested in taking these batteries and integrating them into the products that they're developing. They will go through the same processes that we currently use. We will, as part of that tech transfer, make a so-called blue book available, which is a series of recipes that then the licensees can refer to and implement at their facility. So in terms of the progress that we're making with this mid-scale fab that we've got, we installed a 1,600 square meter fab pretty much on time and on budget last year, in the teeth of the supply chain disruption associated with the pandemic. We opened that in December of last year. You can see a picture there of our local MP cutting the ribbon. And that's a facility that's capable of delivering about 3,500 wafers a year at full capacity, or about 500,000 batteries a year. We've now completed the process qualification, so all of that equipment is fully operational. And what we're doing now is actually optimizing the yield that we get from that equipment to make sure that in terms of the productivity and price point that we reach, we can meet industry expectations. Also, as part of that, we've got product qualification that's in progress. So that means that the initial product that we're creating with the facility is sent away for third-party validation, for halt testing, which is highly accelerated live testing, and also reliability testing. Because of course, the medical device industry is very demanding in terms of asking for proof points of the performance of the batteries. And we want to make sure that we've done our own testing before the batteries go out to customers, because they will be doing validation of the product that they receive as they go through their own product development cycle. So, the initial product will be sold in 2023, and it will be used in preclinical studies. And then the next step is to do the initial clinical studies, so the first trials in humans, followed by extended human trials, regulatory approval, and then of course product launch. And the volume of batteries that these partners need as you go through their own product introduction cycles increases. So you move from initial demand of hundreds of batteries through, of course, to demand for hundreds of thousands of batteries, indeed millions of batteries when you get to the mass market. And that's really what defines our sales ramp over the following, say, 3 years after initial product sales. So, of course, lots of people are interested in what our commercial pipeline looks like. This is actually an extract from our CRM, or a customer relationship management system, where we have a series of companies. The types of companies varies between startups, so relatively modestly sized businesses, similar to ILIKA, to large multinational companies that are listed on the NASDAQ. A lot of US-based companies because of the strength of the medical device industry there, but also some in Europe and also, of course, in Israel, which is a very fertile area for new technology startups. And there's some of the application areas ranging from CRM, so cardiac devices, or pacemakers, through orthodontics and neuromodulation, as we've talked about, and also smart orthopedics and even contact lenses. The reason actually that we interact with startups, because you might say, well, what's the point of dealing with small tech companies, is that actually the way that the whole medical device industry works is that often new technology is developed by startups and SMEs, and then once you get through the approval process, they're often bought by bigger incumbent companies, and the technology gets added to the portfolio that those bigger companies manage, and then the marketing muscle and reach and commercialization capability of those bigger companies can be brought to bear to make a commercial success out of the technology. So although it might be a startup this year, in 2 years' time, it may be part of a very large and successful medical device company. When you look at the quantities of devices in the final column, you say, well, some of those devices are in the hundreds of thousands. It doesn't take many customers like that before you've totally maxed out your fab. And in fact, some of the customers that we've interacted with have already said, look, our projected end markets are bigger than the entire capacity of your fab. But that actually encourages us, because that's a licensing opportunity. So by the time we get through to that mass market, we'll be able to say, well, yeah, that's fine. We've got a stable recipe for the product that you want. We can supply you with 100,000 of those devices right now. But if you are interested in a larger volume of production, then you can take a license and we can transfer it either to your facility or to a third-party facility that is capable of manufacturing those devices under license. Right, so let's change gear a little bit and talk about Goliath. Why are people interested in large format batteries that are solid state for the EV market? Well, first of all, that compact nature of solid state is very attractive to the automotive manufacturers. The volume and weight of the battery pack in an EV is substantial, and anything you can do to lightweight the vehicle and also to make sure that it's compact so that it can be designed into a vehicle that is aesthetically pleasing is going to have a big impact on your customer demand. So people are really interested in that. Also, the high temperature tolerance is of real interest, not only for safety reasons, because a normal lithium-ion cell is probably rated to 60 degrees C. In some parts of the world, in the direct sunlight, you can easily get to temperatures at that level. And if you want to make sure that your pack is intrinsically safe, then having a cell design that is more resilient to those high environmental temperatures is an advantage. But also, you in the normal operation of an EV battery pack, you have to use a pack design that incorporates a cooling system, which is a fluid that's pumped around the battery pack. And then you've got your pumps and your heat exchangers and, of course, the weight of the fluid. And if you can reduce that by using solid-state batteries that are tolerant of higher operating temperatures, and our solid-state batteries can go up to 150 degrees C as opposed to an operating limit of 60 degrees C, then you can actually reduce your pack size and weight even further by minimizing the size of those pumps and heat exchangers. Clearly, a cell that's intrinsically safe and non-flammable is an advantage. And also what's becoming increasingly important is that you need less energy to manufacture solid state, and also they're easier to recycle. So, not many of the lithium-ion cells out there at the minute are recycled. We've seen some investments in the sector in the last year or so, but actually it's quite difficult to make money recycling normal lithium-ion cells because of that toxic liquid electrolyte and also the plastic separator. And of course, we haven't got that in solid state. We've got a ceramic solid electrolyte that allows us to granulate and then extract the useful metals in a more straightforward manner. So I probably don't need to convince you that actually the addressable market for EVs is one that's growing very rapidly. The EV revolution is underway, well and truly, and actually there is far more demand than there is supply at the moment. You know, waiting times for new EVs are pretty long. But you know, consumers have been convinced that the technology is mature, and EVs are being sold in increasingly larger numbers. And you know, ILIKA's technology is very much aligned with this demand. Here's a bit of data from Bloomberg NEF, which is actually the demand forecast for solid-state batteries in Europe and the US. And you can see as we get to the end of the decade that the mass market for solid-state becomes substantial. And actually the price point, which you can read on the left-hand axis, is expected to drop significantly down to levels that are very competitive relative to the price point for lithium-ion. And really the key to that is to get to scale, to get to gigafactory scale for the production of these cells, and then you get the economy of scale associated with that. So, you know, first of all, a bit of a sort of word about the roadmap of development for Goliath, the trajectory that we're on. You can see there a green S-curve, which is the roadmap for Goliath. You can see that it intersects a solid blue line, which is the top end of the S-curve for traditional lithium-ion cells. We're expecting lithium-ion equivalents in you know, Q1 of 2023. And at the moment we are driving through data point D2 towards our first prototype products, P1, which will be available towards the end of this year, early 2023. And that'll be a strong proof point as we then move on towards our minimum viable product, or MVP, and then to even better performing products, P4 and beyond. And of course, lithium-ion isn't standing still. It's a moving target. Engineers are very successful in managing to get additional performance out of the existing technology, and this is absolutely normal for a mature technology where it continues delivering benefits, but eventually solid state will catch up and indeed exceed the performance of normal lithium ion. And that's really why the automotive industry is keen on integrating solid state into their roadmaps going forward. In fact, I think it was Volvo that's just said recently that by 2030, all of their EVs will have solid state cells in them. And there at the bottom, you see a little infographic that explains some of the pack level benefits associated with energy density. Right now, you got a gravimetric cell to pack ratio, that's the GCTP, of about 65%. So that means about 65% of the pack weight is associated with cells, and the remaining 35% relates to, let's call it passive or parasitic weight within the pack. And as we move to 2030 and solid state is adopted, you get away with less cooling, less packaging, and then you can expect that GCTP to increase to about 85%. So only 15% of the total pack weight at that juncture is going to be related to cells. So let's have a look at the technical progress that we've made over the past year or so. There you see a picture of one of our prototype cells in an oversized pack, actually, an oversized pouch. You've got, first of all, last year, some of the progress that we made around an increased number of cycles, so 500 cycles without cell failure, room temperature cycling through some innovation associated with the modified electrolyte, some increased cathode utilization, and then batch reproducibility to demonstrate that we can make the same cells repeatedly. Followed in 2022, so earlier this year, by some mechanical robustness testing that we did. So there's some entertaining videos on YouTube where you can see the pouches being cut and folded. Increased loading approaching D2, that means increased cathode loading. So the cathode is the positive electrode in these cells, and the thicker that you can make that up to a certain degree, the better the energy density. That's then limited really by the amount of lithium that can diffuse in and out of the cathode, but we've been optimizing that, and that's some of the work that we've been carrying on with over the summer, and then matching the capacity of that cathode with the anode, so the negative electrode on the other side of the cell, which is where the lithium is stored when you charge the cell. In terms of initial commercialization targets, we are expecting to enter the market in hyper and supercars, and then actually migrate down to luxury cars, so the high-end vehicles from some of the mainstream OEMs. It's actually quite good being based in Europe, because a lot of the manufacturers of hyper and supercars are based around here, and so it makes interacting with those organizations more straightforward. The reason that that's useful for us is that when we first manufacture our MVP, we will be doing that at mid-scale, so not gigafactory scale, but mega factory scale, so a step down in scale. And of course, the price point associated with those slightly lower manufacturing volumes is a better fit, really, with these addressable markets, which are more concerned with performance of the vehicles rather than the price point. So what we don't want to do is compete on price with some of the gigafactory producers in Asia. So the scale of 100 megawatt hours is sufficient to be able to support 3 platforms for those OEMs. In terms of the scale-up story, what you've got here is a map really of where we've been and where we're going. Right now, we're manufacturing in a pre-pilot facility. We've had some collaborations together with Honda, Jaguar Land Rover, and McLaren. That's been really great to collaborate with them through the low technology readiness levels, or low TRLs. We are now at the point where we have designed our pilot plant transition from pre-pilot to a more automated platform on the same footprint that we currently have, so about 10 kilowatt hours per week, so a tenfold increase on our pre-pilot line. We're going to be starting to implement that shortly. We've also done a lot of design work on the next scale up, which we're hoping to do with the UK BIC. There's some announcements in the public domain about feasibility studies that we've started with them. In fact, one from May of this year. And we've also started a study more recently with some of the equipment vendors to see what sort of equipment we can use to supplement the existing assets that are at the UK BIC. That'll get us through to what we call manufacturing readiness to support real automotive platforms, and then beyond that, towards the end of this decade, we'll be into licensing discussions. So these scale-up studies are really important to allow us to manage risk. Solstice is the process design study that we've already done. That was completed at the end of Q1 of this year. We did that together with Comau. TDAP is an ongoing program that is focused on the forming protocol. So forming is this part of the process where you take a manufactured cell and you cycle it and stabilize its electrochemical performance, and then you release it through to your customers. BUS 100 is an economic study that's designed to allow us to come to a landing on what the likely cost point is for manufacturing at mega scale at the UK BIC. And then STEP, which is the most recent of the studies that we've just started, is all about vendor equipment trials. So running some trials with vendors of equipment that would be suitable to put into the BIC or another mega facility to make sure that they're robust and reproducible and are capable of handling the types of solid state materials that are perhaps different to other solid state manufacturers, and also the materials that you use when you manufacture traditional lithium-ion cells. So the question is, of course, what's the demand for Goliath? Well, we've met with most of the global automotive OEMs now internationally. So we've got quite a rich portfolio of discussions that are ongoing. But what's key for us is to make sure that actually we choose the right partnerships for our scale up, because we've got limited engineering bandwidth. And the initial production capacity is going to be capped by the facilities that we've got access to and that we've invested in. So we need to choose our partnerships carefully. And actually, when we get to P1, we'll be issuing the commercial quotes that our partners are interested in. So that'll be early 2023. A couple of OEMs have actually already signed up. So they've signed evaluation contracts in the expectation of P1, and P1, just to reiterate, is our first prototype cell for customer release, and people have already said they're interested in getting a hold of initial quantities of those for evaluation to see if they can be integrated into their design platform. So now you see our operations director, Brendan McCarthy, holding up one of our early prototypes. So Brendan joined us after his time at the UK BIC, and prior to that, operations director at BMW. So in terms of financials, last year we turned over about £500,000. We saw a drop in grant revenue relative to the prior year because we'd completed a lot of the programs that had been kicked off a couple of years before that. We have intensified our R&D, and that's why our EBITDA loss widened. But we had a healthy cash balance that was as a result of the fundraise that we did last year in July. And this has given us a strong platform for continuing to invest in that R&D and push us through to commercialization and revenue generation. So in terms of what you should look out for in the coming period, well, we're clearly right in the middle of scaling up our Stereax technology, the Stereax production through the Fab activities, with commencement of commercial sales in the next financial year. So that's this financial year actually that we've now started. So it'll be early in 2023 when those sales start. We'll be maturing Goliath technology with our partners, and we've got a series of defined technical milestones that we've just briefly reviewed with our roadmap there. And the commercial opportunity continues to build really for the technology across these very large addressable markets. So I think that concludes my presentation. many thanks for bearing with me while we trotted through that. I'm happy to take a few questions now.
Graham, thank you very much for your presentation. Ladies and gentlemen, please do continue to submit your questions just using the Q&A tab, which is situated in the top right-hand corner of your screen. I'd also like to remind you that a recording of this presentation, along with a copy of the slides and the published Q&A, can be accessed via your investor dashboard. Graham, we received 2 pre-submitted questions from investors, and I want to start off the Q&A session with these. The first one reads as follows. Can you provide a few of the specific deadlines for current orders and order size? Do you anticipate meeting the deadlines for these existing orders and others?
Yeah, so we have got orders that we have received for Stereax once production starts, and we have informed our customers for when they're likely to receive them, which is the end of Q1 2023. Of course, we currently anticipate meeting those timelines and are on track to do so.
Perfect, thank you very much. And the next question here reads as follows. Please give us an update as to the status of your 6-month feasibility study of the possible commercialization production of your Goliath solid-state battery for the automotive industry. Any preliminary findings you can share with the public at this time?
Well, the study that we completed was the one that we did with Comau, which is the Solstice program. And actually, we've got a complete process map for what a mega factory would look like. So we've got a complete blueprint, soup to nuts, for that production. That is very reassuring, actually, that we're able to take technology that we can integrate. Excuse me, just a moment. I'm sorry. Could you do this later? Okay. Yeah. We'll be able to take some technology that we will be able to integrate into an existing lithium-ion production facility and supplement the existing assets that have been installed there.
Graham, thank you very much for that. That concludes the pre-submitted questions. But as you can see, we've received a number of questions throughout today's presentation, and thank you to all the investors for submitting those. Graham, could I just ask you to read out those questions and give responses where it is appropriate to do so, and then I'll pick up from you at the end.
Yes, so here we go. First one is, will you be pre-selling production capacity on the Stereax line, and when will this happen? So we've already started pre-selling production capacity. And in particular, actually just taking initial orders. They are aligned with that commercialization roadmap that we were talking about earlier, where initial orders are in the hundreds of batteries and then ramp up into the hundreds of thousands of volume as you get through to mass market commercialization. Next question is, have you found a new CFO yet? So yeah, we've been running a recruitment process. We are using an executive search agency in order to find the best candidate. We've actually had 2 rounds of interviews, and we have our final round of interviews on Monday, and we expect to be offering one of those candidates the position. In the interim, actually, we've got a CFO who's working for us 1 day a week and is supporting our financial controller. So we have got adequate financial expertise to keep the financial wheels of the business running and making sure that we meet all of our obligations to the market in terms of updating them and filings with Companies House, etc. So I think that's all under control. Here's a question here. What yields are you achieving on the Stereax line? So actually, the individual processes are delivering yields that are in the 90 percentage points, so pretty high yields actually. Of course, when you put the full process together, you get the compounded effect of those yields, and so the total process is currently delivering about 40% yield, and our mission over the next few months is to ramp that up so that we get high 90s yields for each process step, and then an economic outcome for the whole process from beginning to end. Next question here. Implanted medical devices have a very long testing and approval process. Are you talking generically rather than about specific products? This suggests, sorry, I've misread that. As you are talking generically rather than about specific products, this suggests that any product revenue in this area is some years ago. Is this the case? So, okay, so we've already been selling prototype cells to customers who have been evaluating our product in their prototype products. The initial orders that we have coming off our line are associated with the preclinical testing that our customers are planning to do. So there are specific products that are under development with those customers, and actually the excerpt or extract from our CRM system gives you some insight into the fact that there are specific customers with specific products. But it is true that the mass market is some years away, and that's why we are actually ramping up revenue over the next few years rather than saying we're going to be at full capacity straight away. Let's have a look at this. So of the Stereax pipeline opportunities you list, there are no indications of timing, what stage each is at, or probability. Can you offer any more confidence that these prospects are realistic and timely? Well, what I would say is that all of these prospects are at preclinical stage. If our product is to be integrated into those products, that has to be the case, because the battery is intrinsic to regulatory approval. Not all of these products that our customers are developing will get to market. There's a reasonable attrition rate of the pipeline for most of these customers. But the comfort that I can give you is that if just one of those substantial products gets to market, then that could easily consume the entire capacity of our fab. So clearly, by having 16 or so prospects that we are making samples available to, we've got pretty good odds that actually we will consume the capacity of our fab and generate licensing opportunities beyond that. What sort of sales force do you have working on Stereax in terms of numbers, experience, and track record? Okay, so we have a VP of sales and marketing, John Tinson, who's got a great track record in bringing new technology to market. So he's worked for companies like Trump Lasers that market devices into the medical industry. In the US, we've got a business development director who's got a long track record in this specific sector. We've also got a business developer in Israel who covers Europe for us, and one in China who covers Asia. Your timescales for bringing Goliath to market are long. Do you think you're at risk of missing the opportunity? So actually, our timelines for bringing Goliath to market are competitive with other developers of solid-state batteries. However, like the medical device industry, the automotive industry has got a very structured device regulatory approval process associated with it, and Goliath cells need to be integrated into that design process. And so that's why we talk about the design times that we do. There's a very clear progression through A cell, B cell, and then C sample, and making sure that we plan for the production volume that's required at each of those stages is key, and that's why we talk about the scale-up plan that we've got. Actually, when we talk to automotive OEMs, the timelines for Goliath are often very well aligned with their own vehicle production timelines. Why did you not again mention prospects for consumer electrical products? Well, actually, I did mention consumer electrical products. We have a series of discussions under NDA with developers of consumer appliances. They are mainly mobile or handheld appliances that people are developing, and there's some clear opportunities there. We do have a scale-up strategic choice to make in terms of how we meet the needs of those companies, because clearly the format for consumer appliances is different to that for EVs, and we need to make sure that we are getting the best return on investment for our platform. But we are still evaluating those consumer appliance opportunities very closely. So a question here: how are you going to fund the lost revenue due to the delay in production? Yeah, so last year and the year before, we had 2 successful placings, which have given us a bit of a buffer in terms of executing our scale-up plans. When we actually went through the working capital models, we made sure that we had run a number of different scenarios, and so for the moment, actually, our balance sheet is strong enough to absorb the cash flow and cash investment requirements that we've got in order to bring our plans to completion. When will you be putting out revenue projections for the Stereax line? Well, actually, we've given some guidance on that over the years. So we expect that at capacity, our Stereax Fab will be able to generate revenues of about £12.5 million per year. So we expect to ramp up to those levels of revenue generation in about a year from the start of production. And then beyond that, we should be able to add, to double that revenue level through licensing to multiple partners. So what competition is there in the Stereax space, or is anticipated in the short to long term? So I guess the competition really is made up of substitutes, so alternative ways of powering the devices that are currently implanted. So you can use primary batteries, which are much larger, but nevertheless, it's an established technology. So just to explain, a primary battery is one that you just use for the duration of the life of the battery, but it can't be recharged. And so there are some medical devices that use an approach like that. It's also possible to use small capacitors in order to power some devices. They're quite good at generating a pulse of current or a pulse of power to power the devices. The downside of capacitors is that they're electrically quite leaky, so they don't hold current for a particularly long time. So therefore, they need to be recharged regularly. and that's where Stereax cells have got an advantage over capacitors. Let's have a look here. So, what is the likelihood of an established battery company developing its own solid-state technology for either micro batteries or large format batteries for EVs? So, I would say that it is the case that there's a lot of interest in solid state globally. The incumbent EV battery manufacturers are working very hard in this space to come up with solid state devices, solid state alternatives to existing lithium ion. So there is, competition from the usual suspects. So Cattle and BYD in China, SK and LG and Samsung in Korea, and then Panasonic in Japan. So I think it's very likely that they will be working on the subject. But at the same time, we know from our discussions with automotive OEMs that actually technology companies like ILIKA are being turned to for advice and prototypes. And we're seen as being pretty important players in this overall race. With respect to micro batteries, I think because that is more of a specialist niche, perhaps there's less competition there. We're not seeing much competition apart from a few venture capital funded competitors in the US who have normally identified specific applications, often not in medical devices, interestingly, and that's where we see some of the Stereax competition. So let's have a look. I've got one here. How does Goliath SSB technology compare to QuantumScape or other SSB developers? Well, this is a really interesting question because not all solid state batteries are made equal. They don't all take the same chemistry approach that we take. QuantumScape use an anode-less design, which means that when they first make their cells, there is no anode there. It's just a current collector that's placed over the electrolyte. And as when you charge the cell for the first time, you plate out the anode. Solid Power, also in the US, they use a sulfide-based electrolyte. And so basically there are differences in the performance of the cells that result from these different tech approaches, which means that actually the different solutions have got varying applications for the cells. And a bit like actually that we currently see with the lithium ion industry is that there is a big spread of materials that are used right now with lithium ion, and that will probably be the case with solid state going forward. Final question here. You previously talked about industrial applications for Stereax. Are these no longer being pursued alongside medical applications? Actually, we do get a steady stream of interest in Stereax for industrial applications. The key thing that we're always key to do is to make sure that actually the price point matches, because industrial applications are slightly more price sensitive. They can be higher volume, but they're often more price sensitive than medical device applications, and we need to make sure that actually there's a commercial match between the price point we can manufacture at our fab and what our customers want. Thank you.
Graham, thank you very much for that. I think you've addressed all of those questions from investors, and of course the company will review all those questions submitted today and will publish those responses on the Investor Meet Company platform. But just before redirecting investors to provide you with their feedback, which I know is particularly important to yourself and the company, Graham, could I just ask you for a few closing comments?
I'd just like to thank everybody who's taken the time to dial into this presentation. There have been some very well-informed questions, and I always really appreciate the fact that people follow the company's broadcasts. Thank you.
Graham, thanks once again for updating investors today. Could I please ask investors not to close the session, as you'll now be automatically redirected to provide your feedback in order that the management team can better understand your views and expectations. This will only take a few moments to complete, but I'm sure will be greatly valued by the company. On behalf of the management team of ILIKA PLC, we'd like to thank you for attending today's presentation, and good afternoon to you all.